So we talked on the last section about solving equations. I want to talk a little bit more about solving equations because you're going to run into some weird things. So let's look at this example here. So they want us to solve this. If it was me, I would distribute the 2 on the left side. So you get 2x minus 6 is equal to 2x minus 6. And like I was saying in our last video, typically I prefer to have all the x's on one side. So I'm going to subtract 2x from the right and from the left. Get all the x's on the left side. And then I tend to prefer having all my numbers without variables on the right. So I'm going to add 6 to both sides here to get rid of the minus 6 here. So when you do this, you get, on the left side, you get 0 plus, so you get 0 on the left, everything goes away. And then, interestingly enough, on the right side, you also get 0. So normally we end up with like x equals 4 or something like that, but now we have 0 equals 0, the x's are gone. So what do we do with this? This is really bizarre. And so let me ask you this question. Can you think of a number that we could plug in for x that would make this equation true? Because that's what we're trying to do. We're trying to find a solution. So maybe instead of solving this, let's just go back and look at it. If you have x minus 3, so a number minus 3, so, I don't know. Let's try 8. So 8 minus 3 is 5, and double that would be 10. So if you plug in 8 for x, you get 10 over on this side. If you plug in 8 for x here, you get 2 times 8 would be 16, minus 6 would be 10. So 8 is a solution for this, because if you plug 8 in, it makes the left side equal to the right side. How about 12? So if you do 12, you'd have 12 minus 3 would be 9. If you double that, you get 18. So if you plug in 12, you get 18 over here. If you plug in 12 here, you get 2 times 12 is 24. Minus 6 is 18. So we actually have multiple solutions for this. Now, what you'll notice is if you have x minus 3 and you double it, what do you get? You get 2x minus 6. So to say 2 times parentheses x minus 3 is really the same thing as saying 2x minus 6. They look different, but they're the same thing. Which is exactly what you have on the right side. So the question is, for this, like, what could I plug in for x that would make 2x minus 6 equal itself? And the answer is, well, it doesn't really matter what you plug in for x, right? Like, if we plug in 100, will 2 times 100 minus 6 be equal to 2 times 100 minus 6? I think so. So when you have a scenario like this and you simplify down, you get something that's always true, like 0 equals 0, then there's actually an infinite number of solutions for this. So there's a ton of different, basically any number here for x that you plug in will work. Like, seriously, try it. Try negative 12, plug in negative 12, see what you get. So what's weird about this equation, there's no x at the end. There's no x at the end. There's just zeros. Okay, so try to find a value for x that I'm looking at step 3 here, that makes this equation false. Can't do it. If there are no numbers that make this equation false, every value for x makes it true. Then what are the solutions? So we say in scenarios like this that there are an infinite number of solutions. So we say there are infinite solutions. How can we know if there are an infinite number of solutions? When we get to the last step, let's say this. When we get to the last step, we have an equation that is always true. We have an equation that is always true. And by always true, I mean something like, 2x equals 2x, or, 5 equals 5, or 0 equals 0. All right, how about this one? Okay, so let's do this one. So this one looks similar to the last one. So 2x minus 3, let's distribute here. So this will be 2x minus 6 is supposedly equal to 2x minus 5. Now, you can tell this one's going to be a little different. So let's proceed and solve like we normally would. Let's subtract 2x from both sides. And let's add 6 to both sides. And let's see what we get here. So on this side we're going to get 0, and on this side we're going to get negative 5 plus 6 would be 1 actually. So okay, so now we need to figure out a number for x that we could plug in that would make 0 equal 1. Well, 0 is never going to equal 1, so we can't. And if you can try as hard as you want to find a number for x that makes this true, but there are no numbers for x that will make this true. How could 2x minus 6 be the same thing as 2x minus 5, right? Because whatever x is, like if x is 10, 2x is going to be the same as 2x. Like it'll be 20 and 20, right? So you're never going to be able to find something that works in this scenario. So if there are no values of x that can make the equation true, we say that there are no solutions. So instead of infinite solutions, we've swung to the other extreme and say, hey, there's actually nothing that works. How do you know if there are no solutions? So basically, the final equation, instead of always being true, is never true. So the final equation is never true. Is never true. Emphasis on never. So go ahead and flip over on the back of your sheet here. Let's do some more of these. I'm going to distribute and simplify here a little bit. So I have 3n minus 2 is equal to 4n plus 4 minus n minus 10. And I'm going to just simplify a little bit over here on the right side because I got some stuff that can simplify. So on the left I have 3n minus 2. On the right I have 4n minus n is 3n. And then 4 minus 10 would be minus 6. Let's go ahead and subtract 3n from both sides. And we'll see what we get here. So when we do that, we get negative 2 is equal to negative 6. So this, again, this is like the last example we just did. This doesn't make any sense. There's nothing I could plug in for x that would make this work. So this right here, unfortunately, has no solutions. Doesn't matter what you try to plug in for n, it will not work. All right, let's look at example 2. Let's distribute here. So you have 3x plus 6, and that's going to be equal to 4x plus 8. Now, a little quick note here. If you subtract 4x from both sides in order to get all the x's over here, you're going to get a negative x. And you can do that. I just really don't like negative x's. So I'm going to actually go a little backwards here, and I'm going to subtract 3x from both sides. Because what that's going to do is it's going to allow me to have a positive x on the other side, on the right side. And then I'm going to subtract 8 from both sides because I decided to bring all the x's over to the right side. I'm going to get all the numbers over on the left side here. So what do we have when we do this? We're going to have, that's 0. 6 minus 8 is negative 2. And that's 0 right there. And then we'll have x here. So x is negative 2 in this scenario. So apparently negative 2 works. All right, example 3. Solve for x. Okay. Oh man, this one's kind of gross. Okay, so in scenarios like this, probably the best thing to do would be to multiply by 2 on both sides. You cannot add 4 to both sides here because you're dividing by 2. So I would probably, if it was me, I would probably multiply by 2 on both sides in this scenario. So let's multiply both sides by 2. The whole point of multiplying by 2 on the left side here is to get rid of that 2 on the bottom. So I'm not going to actually multiply the top part by 2 because the 2 that we're multiplying by here and this 2, they essentially cancel. When you divide them, it's a 1. So 2 over 2 is 1. So all right, how about on the right side here? So if we distribute this 2 here, we get 2x minus 2 times 2 is 4. And then we're in this first situation that we dealt with on the last page there, right? So you have 2x minus 4 is equal to itself. Honestly, if you get down to this point, you're more than welcome to just say infinite solutions, because it's going to be pretty obvious if we subtract 2 from both sides and add 4 to both sides, we're going to get 0 equals 0. So if you ever get that something is equal to itself, then you have an infinite number of solutions there. All right, let's do this one. Solve for m. So you can distribute here if you want. You can combine the m's inside the parentheses. It doesn't really matter. I'll probably just distribute. Some of my other math teachers might judge me for that, but whatever. So you'll have 2m plus 2 times 2 is 4, plus another 2m. And on the left side, we're going to keep our 4m minus 3. On the right side, let's simplify a little bit. So you have 2m plus 2m, that's 4m plus 4. And if you subtract 4m from both sides, we're going to have a problem here. Right? So if you subtract 4m, you're going to have negative 3 is equal to 4. And that's dumb. That can never be true. So this will be no solutions. No solutions. All right, I think that's it.